In this video we are going to convert that blank pallet into a fixture pallet for machining these little guys. We're going to machine 8 at a time, second op, so we're going to put 8 little cavities into there. There's a quick tutorial on how we get that done.
Okay, so we're going to run through the CAD and CAM side of programming a pallet quickly, and we'll hop in between this and the actual machining of the pallet. So to start off, I've modeled up a block here that is 100 by 100 millimeters. The pallet's materials usually between 100 and 105 millimeters square. We leave the rough edge because, well, more material for you, less effort for us. The bottom of the pallet will be machined to 98 by 98 and all the features will be put in. So then we I only model a single hole in the bottom that is on a 80 diameter pitch, a single 10 millimeter hole that is where the locating pin that our X, Y is set on the pallets, in my case G57. So we modeled that in, then I chamfered the corner or filleted the corners because I want it to be pretty, and then I pulled in an existing model of this clamp that I'm going to make a fixture for. I extruded a pocket for it, and then I went through and just widened the pocket up a little bit, and then cut this relief for the clamp to fit in. Chamfered the corners, filleted the corners because, well, end mills have radiuses, and then I pocketed out the area there so that I can reach in with a 4mm diameter end mill and not have any corners that will interfere with my parts locating. And then I put in the hole for the car line clamp, which is over there. I put it 0.25 back just so that I knew I'd have enough clearance. Once I had that one set of features modeled, I then arrayed it, and then I mirrored it, and then I arrayed my actual components as well so that they were all in place. And finally I added some text for the engraving. We go over to the manufacturing tab. We're going to start off by setting up our work setup. In this case I selected the top face as the Z-axis and the front edge as the X-axis, and then I said selected point as my origin, which is the center of that hole. The important thing here is to make sure your model is the correct thickness. You'll need to measure your pallet just to make sure, just in case there's any variance. In this case we had to settle up at 23.75 to get it to clean up nicely. Then we do a facing pass.
Okay, so there we go. We've taken the top off of the blank pallet, so we have a nice known Z height. The pallet is clocked from the dowel pin and the surface, so that is set in my machine as G57 and it never changes. So this is programmed according to that.
Where we take off 0.25 of a mil. I rough out the perimeter. In this case I only dropped down 14 millimeters because I knew it would clean up the step. The step on the bottom of the pallet is 12 millimeters deep. So going 14 deep here, you know you're going to clean it up easily. Then we just went around the perimeter with a finishing pass, and then Adaptive cleared out the bulk of the material with a larger cutter, in this case a 6mm end mill.
The pockets roughed out with a 6mm end mill.
Then we came in with a 4mm end mill. Adaptive cleared out the pockets. Then we finished them, finished the contours, added chamfers everywhere, spot drilled the holes, did the engraving using the NC spotting drill just because it was in the machine, drilled the holes and tapped them.
Okay, there we go. That's the 4mm rougher done. Now we're going to put chamfers on things because that's what separates us from the animals. Okay, so that's the chamfers complete and the engraving. So we can actually be fancy. I don't know why I'm doing that. So on there we've labeled what it is because we need to be fancy. It's all been sensor drilled, all the edges have been broken. We're now going to come in and drill the holes and thread mill them. That way. Okay, so now we're just going to check the threads quick. It's almost like I have my preset saved. Okay, so now we're going to use these little, similar to a car line clamp that I made a few years ago. Put in the countersink screw, and these guys will just drop in, slide up against, and clamp. And that's it, clamped. So I'm going to load this whole fixture up, and then we'll go through machining it.
Then when it comes to running the part, you're going to want to create another setup, and in this case I selected all the bodies and told it that there's no additional stock, so relative size stock with no additional stock. And then I selected the same thing, selected the top of the job for my Z-axis, selected my X-axis, and selected the same point as my previous setup. And then in my setup, under post processes, work coordinates, I set it to 4. That'll give me a G57 when I post the code out.
Okay, that's the fixture fully loaded. We're using these little car line clamps that I made. Can't sell them because that infringes on a patent, but there's nothing stopping me from making them myself and for internal use. So that just pushes the part that way and clamps it in place. Then we're going to come in and we're going to pocket all 8 of these, and then we'll swap them out and run another 8. But that is the basic gist of how to make a pallet for the anchor point 0-point system. So that allows me to take this out now, swap in a different job, and run something else. Or when this job comes around again, I can throw it back in there with a very high degree of repeatability and don't have to make the fixture again or don't have to make soft jaws again. And with the cost of the pallet being a pull stud and about $5 worth of aluminium, it's cost effective to make one-off fixturing like this. Now let's pop that back on.